Hey guys, welcome back. It is day 13, and today we're going to be talking about abstract classes, abstract methods, instance of, which is like a thing you can do, and typecasting. It's a lot of stuff. This is going to be jam-packed today, so get excited. So what are we talking about? Abstract classes first. And so abstract classes in Java are classes with abstract methods, which are methods that are declared without an implementation. Abstract classes may have abstract and non-abstract methods, but they cannot be initialized, straight from that class because some of the methods obviously aren't implemented. Abstract methods don't have a body, and by implemented we mean they don't have code inside them. So it just says, public get age or something, or public, get dictionary, and then, it has a semicolon after and doesn't actually have the open and closed curly brackets that you usually do in a method. It just says, this is a method I'm going to have, but I'm not going to do anything with it yet. But if we can't initialize these classes, how can we use them? Well, kind of like what I was talking about in the last video, we subclass them. And so you'll make like a big class with a bunch of abstract methods, and then you'll subclass it, and each, subclass, each dog, cat, unicorn will have different implementations of this abstract method you declared in, say, animal. This will make more sense later, but what do we do first? We jump in the code and we see what happens, and hopefully things make sense. That's kind of what we do here. And so NetBeans will fire up here, and we are going to continue working on our animal class that we started in the last video. I know, we're actually continuing something that we started. Very exciting! And so here is our animal class. If you don't have yours open right now, if you were messing around in here, doing your crazy codey things, you can go to File. It'll probably be in your recent projects, but if not, go to Open Project and find it within your directories, files, stuff like that. Once you have it open, you can see that we can create just an animal, just a dog, and just a cat. But since dog and cat are basically animals, why would we ever want to create like an animal, by itself? Like, why create animal and then dog and cat? But dog and cat are more specific, so why not just have more specific things, like have dog, cat, lamb, unicorn, butterfly, and have all of them like that, and they can just extend or share this class animal where they'll have similar methods, but we never actually want to create an animal. That's what we're going to be doing here. We are going to make it so that animals can never be instantiated themselves. Like, you can't just create an animal, I don't know what it is, it's just an animal. Like, you're not going to be able to do that. You'll just be able to create like dog or cat, and then whatever other class, you want to implement, whatever animal you want to create. But of course, since the dog and cat have similar traits, we're still going to want something with our animal so that we don't have to write eat, sleep, stuff like that inside of our dog and cat classes. So how do we group them in this abstract way? Well, with an abstract class. We can make animals so it won't be instantiated, but we can still have this animal type grouping with our dog and cat. I've been talking for a while, so let's just, write things and hopefully it will work out. So we are going to write abstract before our class here. And notice when I go down here in our main, it's going to say animal is abstract. It can't be instantiated. So we're going to have to take all of these little animal things out of our code. So I'm just going to delete that. We scroll down. Animal is not a thing. You have to be more specific than that. That is what we're doing with this. And we'll just kind of take that away because that's from the last video. And we'll just keep the stuff here for now. So if we scroll back up, we have an abstract class. Okay, but there's nothing else different about it. We just can't instantiate it. Well, let's actually make it abstract. Right now we have 3 not abstract methods. We have getAge, eat, and then our constructor. How do we make an abstract method that can actually be used by our dog and cat? Well, what if we want to say instead of an animal is eating, we could say a cat is eating or a dog is eating. That means that eat should have different implementations for both dog and cat. Eat, the function, should have the same name. It should do, eat, but they should do different things based on whether it's a dog or cat. This is how we're going to do abstract methods. So how do we do this? We're going to take out this little code here. We're going to add a semicolon at the end, and then we are going to add abstract. So we'll say abstract. There we go. We'll save it up. And now is an abstract class. Notice I got errors for both my dog and cat. Let's see what the error is. Dog is not abstract and does not override the abstract method in animal eat. What does this mean? Well, basically we have 2 choices here. Dog, because it extends animal, it has to do something with this method called eat. It either has to implement eat, which means we have to do, if we go here, public void eat, and then we print out system.out.println, and then we'll say a dog is eating. It either has to do that, or the dog class itself has to be abstract and be unable to instantiate it. So the other option is public abstract eats, making it even more abstract. So maybe you have a specific type of dog that you want to eat, like, I don't know, a poodle. Like you could say a poodle is eating if you want to implement like a poodle class, and say poodles do different things than golden retrievers. Golden retrievers and poodles, they eat in different ways. We want different descriptions for them. And then if that was the case, we would want to make this abstract. But that is not the case. Dog is kind of like the last layer of our onion here. We have our object class, animal class, dog class, that's the end. So we want to implement this function here by adding a body to it. And we save, and the error goes away because we have implemented eat. And so now we can instantiate our dog, and it will have this method eat, which is pretty cool. Then we'll go to our cat here, and again, it's going to error. It's going to say we need to do the same thing here. So I'm just going to copy this, go over here to our cat, do a couple enters here, and paste it. And instead of a dog is eating, we're saying a cat is eating. The error goes away because we either had two choices, we could abstract it, or we implemented the function, and therefore the error goes away, which is awesome. So seeing what this does here, we can go back to our animal class, and we'll actually delete all this stuff. We'll keep our cat and dog, but we can actually do d.eat, open close parentheses, and c.eat, open close parentheses, and they're going to print different things. So if we press play here, it'll say an animal has been created, a dog has been created, because a dog is both an animal and a dog. There it goes again with the animal, and then it will say a dog is eating, a cat is eating. We called the same eat function, and they're both animals, but because we had different implementations, we had separate implementations with the whole abstractify idea, they printed out different things. Another cool thing we can do with this type of idea is override our methods from the superclass. Meaning, say if the animal has a method called drink, it prints out that the animal drinks, it says the animal is drinking. We can actually override that method rather than using like this abstraction idea in our dog class and print out, the dog is drinking instead. A class doesn't need to be abstract to do this, but it's just a cool little thing that comes with knowing what inheritance and subclassing, what this idea of like reusing code, what it can do for you and how it can make you more efficient in code, better. So let's do something like this. If we go back to our animal class, we can implement a method, and this will not be an abstract method, this will just be a non-abstract method, because non-abstract classes can do the same idea of overriding methods too. We can do public void sleep, open close parentheses, open close curly bracket, and we can do inside of here system.out.println, a animal is sleeping, do that little semicolon there, and then when I mean overriding a method inside of our dog class, we can also have a method called sleep. We can do public void sleep, open close parentheses, system.out.println, and we are actually overriding this method, and we can do a dog is sleeping. So now if I go to our main method and we go scroll and we do d.sleep and then c.sleep, it will print out the dog is sleeping, and then under cat, because we didn't override the method, it's just going to say an animal is sleeping. So if we press play, a dog is sleeping because we overwrote the method sleep inside of animal in our dog class. We did sleep, and that took precedence over our animal sleep. Then we have our cat class. It did not have a sleep method, and so it went directly to our animal sleep, which was implemented as an animal is sleeping. And that should be an animal, not a animal, so we will add a in there. Grammar, guys. Yeah, it's important. Now, if we want to say a cat is sleeping, we can do inside of our cat method, we can go down here, we can say public void sleep, open close parentheses, open close curly bracket, and inside of here we will do system.out.println, a cat is sleeping, do the semicolon, press play, and there we have a cat is sleeping instead of an animal sleeping, because our overriding of the method took precedence over our animal sleep method. But in order for this to work, we have to make sure this signature is the exact same as the animal signature. Here we had returning nothing, and it was called exactly sleep. If they're not exactly the same, then there'll be different methods, and hence you won't be calling the same thing. So if I call c.sleep, it'll call like the animal method, but in our cat, like say if I said sleepy sleep or something, then it won't be the same method. And so c.sleep will actually still do the animal. So if I press play, obviously different method, so it's going to say an animal is sleeping. But if I do like c.sleepy sleep, it would call obviously the cat method. Make sense? So changing back sleepy sleep to sleep, there we go. And to relate this to the real world, it's kind of like how you can inherit traits from your parents. Like say your parents have blue eyes, you can change your blue eyes to brown eyes with colored contacts. Only you and your parents would know you originally had blue eyes unless you told other people other objects. And so when we call it in the main method here, when we do d.sleep, you as the user only know the dog is sleeping, but behind the scenes we really know it was an animal sleeping and then it was overwritten by the dog. Hence, you originally had blue eyes and then you overwrote it with your brown contacts. And so other people see you as having brown eyes, even though you may have had blue eyes originally. However, when we're talking about the difference between abstract classes and overriding methods, it's important to note that classes that extend abstract classes, they have to implement like the abstract class method. And so here when we had our animal abstract class, we had this abstract method eat. Both dog and cat had to implement eat because they extended the animal class. However, in our sleep method, when we had this method sleep that was already implemented inside of our animal class, we didn't necessarily have to overwrite it in our dog class or our cat class, we just had the choice to, which is why like other classes that aren't abstract can do this idea of overriding methods as well. But why is this true? Well, with our abstract classes, there's a point like in the layers where the method isn't implemented. And when the method isn't implemented, there's no code for the program to execute. It doesn't know what to do because it's abstract and someone else is handling it later. But with the overriding of methods, there's an implementation at each level. So if you don't implement it at like a lower level, it's just going to go back to the superclass, method and grab that. But of course, if you implement it in a subclass, like deeper down, at our cat and dog level, obviously that will overwrite the superclass method. And now we are going to talk about casting. We have this thing, it's called casting. In casting, you tell the compiler, which is basically this thing like inside of here that whenever I type in like this, it tells me I have an error. Like that's what the compiler is doing for us. If you have a syntax error, that's what it catches. So basically in casting, you tell the compiler that your object, say of type animal, is actually a more specific thing, dog, and then it gives you access to all of the dog methods. So it kind of solves the problem that we ran into in the last video where you couldn't go from like animal back to dog. This is what casting allows us to do so that we get all of those dog methods without a compiler error. But what does this actually mean? Well, if we take away our little thing there and go to our main method, we can implement some things. We are going to write a little comment here saying casting, and then we're going to write object dog equals new dog, and then we're going to write dog real dog equals dog dog. So what does this do? Well, it allows us to have like a new dog. We know it's an object, it's a dog. But if we didn't have this line here, we would lose all of the dog properties. So if we do dog dot, here we have these methods, but we don't have the dog methods that were like rough, sleep, eat. We don't have those anymore. How do we get them back? Well, we as the programmer know that our object dog is a real dog, and so we can convert it back to a real dog by saying dog, real dog, and then saying, I know this is a dog. Compiler, pretend this is a dog. And so if we go real dog dot eat, rough, we can do all these things, and we'll actually do that to see what happens. And so if we press play here, it says the dog says rough, so we had this object casting, there we go. Why would you want to do this? Well, there might be a point in your program where you don't know what a certain type will be until a later point in the program. Or you might want many types of objects to use the same method. Remember the problem we had with our array thing that we did a couple days ago? We couldn't use the same method for our string array and our int array. This would be the solver for that. We could make everything an object, and then based on our previous knowledge of what it was before, we knew we instantiated it as a dog, but we set it equal to an object so that we could use this method on it, and then we can cast it back to a dog by saying dog dog. There you go. And so we put the class we want to cast it to here, and then the variable we are making a dog via casting, but it should have already been a dog from the first place or else it'll error. That is, what we do. Another example of this would be doing object str equals, est, that's a string. And then we could say real s equals string here, and then we can do str, and we can't just do that. We have to have string as the data type, real S as our variable name, and then add a semicolon here. String is our data type, str is the thing that we know is a string that we're casting. There we go. And then we can do real S dot, and now we have access to all of the string methods, kind of like we did with our dog. Making sense, I hope, and so we'll do just real S. I don't know. We can say get bytes, and then we'll get this byte array, but we'll throw it out because we're not saving it. As programmers, we usually go from something bigger and less defined to something more specific when we're doing casting, but that's not always the case. So now we're going to have another little trick question here. What do you think will happen when we do this? And so we'll do a what happens when ... And we're going to write some code and see what happens. So what if we do dog, doggy equals new dog, creating a new dog, and then we do if D instance of animal, which basically means is D an instance of the animal class? Here the answer is yes, because a dog is also an animal, which is also an object. Hierarchy, superclass, subclass, I hope that's ringing some bells. And then we'll do an open close curly bracket. There we go. And inside of here we will do animal equals, and then we'll cast animal and do doggy. So we'll make our doggy an animal, and then we'll do animal.sleep, open close parentheses, and then outside of here we will do doggy.sleep. So what is going to happen? Well, inside of our if instance of, it will do if D, and this should be doggy because that's the thing we created and that's the thing we're messing with here. If doggy is an instance of animal, which it is, then we're going to create this variable called animal. We'll do animal doggy. We will make doggy an animal even though it already was an animal, and then we will say animal.sleep. What will happen? Will it do, if we go scroll up here, will it do an animal is sleeping or will it do a dog is sleeping? Well, we casted it. What do you think will happen? And then obviously doggy.sleep will be a dog is sleeping, but what about this animal.sleep since we used casting? Let's see what happens. If we press play, it will say a dog is sleeping, a dog is sleeping. Even though we casted like animal to doggy, even though doggy was already an animal, we don't lose like the essence of the dog. Basically what this line means is that it doesn't matter what doggy was before. We just are now guaranteed that when we use animal, we're going to have all of the animal methods. So if I do animal dot, we're going to have all of the animal methods here. Get age, we won't have ref, we won't have the dog methods because we casted it to an animal. But secretly, they're hidden, they're there. And the overwritten methods are preserved with this casting operation. Kind of interesting, huh? So that is the end of this video. Today we learned about abstract methods, abstract classes, what it all means. We learned that an abstract method is basically a method without the code implementation, without the curly brackets. It just says, I'm creating a method, but I'm not implementing it yet. We learned that abstract classes cannot be implemented directly because they don't have implementation for some of those methods. So how do we use it? Well, we subclass it. We create subclasses that extend this animal class that have like a superclass as the animal and then something else as the subclass, and then we can instantiate the subclass to then use the methods that are in, the animal class. And whenever we're extending an abstract class, that class that's extending it, the dog or cat, they either have to implement the abstract methods or they have to be abstract classes themselves and be subclassed again by another class in order to be instantiated themselves. We learned the difference between abstract methods and overriding methods. Abstract methods had to be implemented at a certain level within the onion, but overwritten methods were implemented at each level, and therefore you didn't have to overwrite them if you didn't want to, whereas with the abstract you had to implement them at some point in order to instantiate an instance of that class. And lastly, we talked about casting. We used casting to gain access to certain methods or certain, objects down here. If we knew an object was of a certain instance, like we did a new dog, and then we actually made it equal an object so we could use some methods on it, we could then go back and use our dog methods by doing the casting and making it be and act like a dog again inside of our program through tricking the compiler. And then we had a little trick question down here. We had a dog, which is actually an animal, would be recasted to an animal, and saw that the methods we overwrote were still preserved. And so when we did animal.sleep, it actually printed out a dog is sleeping rather than an animal is sleeping because, we overwrote it and that was preserved, which is great. And so that's it for this video. The HACKERRANK challenge is down below in the description, and if you have any questions, feel free to leave a comment on this video. I hope you learned something, and I will see you tomorrow.